Fidelity is the degree to which the made prototype resembles an imagined manufactured product. Now, prototypes will exist across a wide range of fidelity, and generally they fit into three categories: low, medium, and high fidelity. Now, the goal of any prototype is ultimately to exist as a solution to the design challenge, but unfortunately, prototypes exist on a spectrum of completion. Therefore, the goal of your prototype is to be a test version of an idealized version, and to demonstrate one or more desired functions. Regardless of their fidelity, prototypes share several similar characteristics. First of all, they're built individually. Second, they're built from the best materials available. Third, prototypes are built within the constraints of the technical expertise of the team. They often contain artisan-based defects. At the left end of this spectrum are low-fidelity prototypes. These versions rarely resemble a manufactured product in function or in features. So what do these low-fidelity prototypes look like? Often, they're made of low-cost materials, for example, paper or cardboard or foam. They could exist as a sketch or a diagram. They could be the wrong scale, they could be larger or smaller. Low-fidelity prototypes are often ugly. This is okay. When building low-fidelity prototypes, it's all right to cut corners or skip certain features in order to achieve the goal of the prototype. Making low-fidelity prototypes requires almost no knowledge of how to make things, because you're building using low-cost, user-friendly materials like scissors, tape, glue, and your hands. The goal of a low-fidelity prototype is to build quickly and manufacture rapidly to test ideas. With medium-fidelity prototypes, aspects of the prototype begin to reflect the manufactured product, but not all aspects. So what does a medium-fidelity prototype look like? A medium-fidelity prototype holds its shape, it's at the correct scale, and the main elements and functions are represented. Making a medium-fidelity prototype may require some additional knowledge of the making process, and some tools used for medium-fidelity prototypes include laser cutters, saws, 3D printers, clay, and molding. Medium-fidelity prototypes definitely take more time to assemble than low-fidelity prototypes. With high-fidelity prototypes, aspects of the prototype begin to approach a manufactured product. However, your prototype still may have artisanal defects and may typically be made one at a time. What do high-fidelity prototypes look like? Well, high-fidelity prototypes are built to the correct scale, they have the main functions or features, and the prototype is refined and looks professional. Making a high-fidelity prototype may require some knowledge of one or more advanced prototyping techniques. And examples of more advanced tools and techniques that you would use include laser cutters, 3D printers, injection molders, or advanced machining. Once a high-fidelity prototype is reached, teams' manufacturing process should be reproducible so that prototypes can be built often. Often teams don't make it to the stage of a high-fidelity prototype in one semester or less, and this is okay. One main feature of the prototyping process is the evolution of the prototype's critical features and functions. One thing to consider while prototyping is the issue of prototyping one component versus the integrated whole. There could be times when you decompose your project into components and choose to rapidly evolve one individual component many times while the other components remain constant. So, for example, if your project needs a handle, you might choose to make many prototypes of that handle while the rest of the device is unchanged. Teams might also choose to evolve the integrated or whole prototype at once. Many projects have a progression from low to medium to high fidelity. And during this process, two difficult questions may come up. First, teams may question what differentiates a medium-fidelity prototype from a high-fidelity prototype. Second, teams may also ask, how do they know when to move on to a medium-fidelity prototype? There are several characteristics and features that differentiate a low-fidelity prototype from a medium-fidelity prototype? A medium-fidelity prototype will have more components that are functional in nature instead of representational. A medium-fidelity prototype might have less gaps, overlaps, or jagged edges. A medium-fidelity prototype also will have satisfied at least a couple of the design criteria. Finally, a medium-fidelity prototype will have some successful integration of components. Another big question teams will have is, when is it time to move on to a medium-fidelity prototype? Some of the answers might be when you've achieved the goals of your current prototype. Another reason might be if several proof-of-concept models work, you might be ready for a medium-fidelity prototype, or even an integrated prototype. When you've reached a practical limit of what you can build and test with a low-fidelity prototype, it really is time to move on to a medium-fidelity prototype. In summary, understanding what low, medium, and high fidelity means can help teams to articulate their prototype goals. And this also helps teams to figure out and establish their prototyping schedule. So as you watch the next series of videos, keep in mind the meanings of low, medium, and high fidelity.